Hello students, welcome to the another session. Today we will be discussing about the differentiation. Okay, so already you discussed about we learned about the what is the continuity differentiability. So once the function is differentiable, what is the value of that one we need to discuss. So here what I'm going to discuss right now is what is the first principle of derivative. The first principle of derivative is y is equal to f of x is any function. Y is equal to f of x is any function is continuous and differentiable at x is equal to a. If it is continuous and differentiable at x is equal to a, what is the derivative of f of x at x is equal to a? That is denoted by f dash of a. Or this is dy by dx where at x is equal to a. So this value can be limit extending to a f of x minus f of a by x minus a. If limit this one exists, this value is the derivative of the function. So, for example, limit extending to a minus f of x minus f of a by x minus a, we call it as left derivative, and limit extending to a plus f of x minus f of a by x minus a is equal to f dash of a plus. This is called the right derivative. Now, this is the derivative at a point. I want the a general formula for derivative of f of x, generalized thing. So that is f dash of x. This is limit h tending to 0 f of x plus h minus f of x by h. This is called the first principle of derivative. What you call this one? First principle of derivative. Okay. F dash of x is equal limit h tending to 0 f of x plus h minus f of x by h is equal. If this value is finite, the derivative of the function will come. This is the first principle of derivative. So in this chapter, mainly we concentrate on the approach of how to find the derivative of different functions. So let us look at some of key formulas of the derivatives. Derivative of constant is 0. Means if a function is a constant function, okay, the function is a constant function. Constant function means what happened? Irrespective of x, you will have the same value of this one. So this is. So as x is changing, y value is not changing. What is the derivative? Change in y with respect to change in x. As the change in x is very small going to 0. So in the constant value will be 0. And one more thing is derivative is if you take y is equal to f of x as a curve, its a derivative at a point represents the slope of the tangent at that particular point. If you take s is equal to displacement curve with respect to time t, f dash of t gives us the velocity, f double dash of t gives us the acceleration. And derivative of x power n is equal to n into x power n minus 1. And one should remember all these primary formulas. Everyone has to remember this formula if you want to do any derivative problem. Not only derivative problem, anything related to slopes, tangents, etc. And even increasing, decreasing also, we require to do all these things. D by dx of e power x is e power x. A power x is a power x into log a. Derivative of mod x is mod x by x if x is not equal to 0. If x is equal to 0, it is not differentiable. But derivative of mod x can be written as either plus 1 minus 1. If x is positive plus 1, x is negative minus 1. Derivative of log mod x is 1 by x. Derivative of log mod x base a. So when you want to do log mod x base a, I can write it as log mod x base e into log e base x, sorry, e base a. Okay, or you can write it as log mod x base e by log a base e. So log a base e, we can write log a. Derivative of root x is 1 by 2 root x. Derivative of sin x, derivative of tan x, derivative of sin cos x, everything. These are hyperbolic only for MSET point of view. You need to remember hyperbolic function. Okay. And derivative of sin inverse x is 1 by. The domain is very, very important. Okay. And the next formula, derivative of step x. What is the derivative of step x? If you look at greatest integer function, so step x 0 to 1 value will be 0, 1 to 2 value is 1, then 2, then 3, like this. So what is this one? When it is non-integer, the slope is equal to 0. Where integer, it is discontinuous, does not exist where x belongs to z. Cos hyperbolic x. So if you have any problem with this hyperbolic, you write here cos hx e power x plus e power minus x by 2. Sin hx e power x minus e power minus x by 2. Derivative of tan hx secant h square x. Cot hx minus cosecant h square x. Secant hx minus secant hx tan hx. Cosecant hx minus cosecant hx cot hx. These are the hyperbolic also very important as per MSET point of view. Okay, right. Derivative of sin h inverse x, derivative of cos h inverse of x. So what is derivative of sin h inverse? First of all, you should know what is sin h inverse of x, which is equal to log of x plus root over 1 plus x square. Cos hx, cos h inverse x, log of, okay, x plus root over x square minus 1, tan hx, etc. And y is differentiable function, dx by dy is equal to minus dy by dx also we can write. Okay. And y is equal to f of t and x is equal to g of t. In this case, dy by dx is equal to dy by dt by dx by dt. This is the parametric form of the derivative. Okay. Y is differentiable function. We are writing this one. U and V are two differentiable functions. Derivative of this one and U by V. So here important things I want to explain you. Once look at here. If Z is equal to U into V, so dz by dx is equal to derivative of first function into second function plus first function into integral of second function. Z is equal to U by V. You can write this formula derivation from here you will get U into V to the power of minus 1. From there you can check it out. But here product of two, if more functions are there, z is equal to u into v into w. I need dz by dx. Simply differentiate this one by assuming all other things are constant, plus next differentiate this one u into dv by dx into w plus u into v into dw by dx. And for example, z is equal to like f of x into g of x into h of x. Here, like this, more functions are there. I suggest you to go for log z. When you go for log z, it will be log f of x plus log g of x plus log h of x. So the calculation point will become easy. And if it is of the form y is equal to, so what we are going to do is y is equal to square root of f of x plus, because it is going to infinite many times, this value is also be y. So y square is equal to f of x plus y. So y square minus y is equal to f of x. Now you differentiate this one with respect to x. So now, what will be the types of differentiation? Basically, what are the things we need to look when you are doing the derivative? First one is the chain rule. So y is equal to like f of g of x is there, then dy by dx will be equal to f dash of g of x into g dash of x. And this chain rule very much important when if y is in terms of t and x is also in terms of t, and dy by dx, it is simply f dash of t by g of t. Till here there is no problem. The problem comes the next one. When you want to go ahead with d square y by dx square, this is d by dx of this whole thing, let us say h of t. So it will be h of t. So what we will do is we will differentiate this one, but we forget to write dt by dx. So this is very important under the chain rule. Here f of g of h of whatever the things are there, continuously you need to do for that. Parametric differentiation, when y is in terms of t, x is in terms of t, dy by dx is differentiate y with respect to t, differentiate x with respect to t. And when the second differentiation comes, this one. So this value will be h dash of t into this value is 1 by dx by dt. You can write g dash of t. Next one is function to the power of function. Function to the power of function. So simply take log is equal to g of x into log f of x. Now 1 by y dy by dx is equal to g dash of x into log f of x plus g of x into derivative of log f of x is 1 by f of x into f dash of x. And also this logarithm will be useful where z is equal to u into v into w, etc. functions are there. So in this case also, you can take log z is equal to log u plus log v plus log w, etc. etc. And the next one, second order derivative. So when function is successively differentiable, y is equal to f of x. First derivative, we write it as f dash of x. If you differentiate again, you will be getting second thing. If you do one more time, you will be getting. So you can do this one successively. You can do successively. Second order derivative. Generally, second order derivative means if you take a question like y is equal to e, e, a e power x plus b e power minus x. What is y dash? A e power x minus b e power minus x. If you differentiate again, y double dash a e power x plus b e power minus x. So here y double dash is equal to y. This is called the differential equation. Second order and the parametric. When these two combinations, question comes on combination, you need to be very careful because at that time generally people miss out on the chain rule. People miss out on the chain rule. Okay. And one more type of question generally people may ask, what is that? Like y is equal to sine inverse of x. What is dy by dx is equal to 1 by root over 1 minus x square. Okay. So here root over 1 minus y. Okay. So from here you write it as root over 1 minus x square into y dash is equal to 0. Differentiate again. Root over 1 minus x square into derivative of y dash is y double dash. Yes, derivative of this one is 1 by 2 root over 1 minus x square. Derivative of x square is 2x into 0. 2, 2 is cancelled. Cross multiplication. 1 minus x square into y double dash minus x square. Maybe apart from this one, we're going to get the answers. Okay, thank you. In differentiation, you have to remember the formulas carefully.